In this video, we generate the trendline and polynomials of the EXPONDIST using incomplete gamma function in its Taylor-Maclaurin series sum and LINEST polynomial regression. We begin with the dataset of the EXPONDIST. So ARRAY formula, EXPONDIST of the x values, our lambda is 1 and 0 because this is the probability density function. And the cumulative distribution function, array formula, EXPONDIST of the x values, our lambda is 1 and 1 because this is cumulative distribution function. And the Taylor-Maclaurin series sum. So we begin with the series sum, which is the summation of a times x to the power n plus 1, where a is the coefficient, negative 1 to the power n over factorial n times n, the quantity n plus 1. And our value of n is from 0 to infinity. In this case, 16 is good enough as an approximation. So our coefficient will be negative 1 raised to the power n divided by, there are two parts. First part is factorial n. The second part is the quantity n plus 1. N plus 1. Now we continue with the series sum, which is array formula, series sum of the x values raised to the power n plus 1. N plus 1 starts from 1, incremented by n, which is 0, 2, 4, 6. So the increment of n is 1. And the coefficient, this range. And enter. And we'll chart this. Insert chart. And we will use scatter chart. Just column A as label. And for the series, you show the trend line. Polynomial to the 6th degree. For the equation, for the label, use the equation. For the legend, position at the bottom. And for this area, we don't need this area, so we delete this. And for the series, there's no green, yellow, so we change the color yellow to green. For the size, so the point size, all series will be maximum point size, except for the red one, the expansion. The point size will be none, but the line's thickness will be maxed. So here's our trend line and polynomial to the 6th degree. Next, we calculate this polynomial regression coefficient using LINEST. To do that, we complete the LINEST matrix. So we begin with the power, which is transpose 0 to 6. And the elements of the matrix, which is array formula of the x values raised to the power. This is raised to the power 0 to 6. Enter. Now we calculate LINEST. So LINEST, that is the polynomial regression coefficients, dot y and dot x. Again, for the expansion, LINEST, dot y and dot x. And the cumulative distribution function, LINEST, theta y, gamma, theta x. And we modify this. So our value of k will be data validation, list of items, 0, comma 1. Begin with 0. So this will be modified. So right outside the series sum, we multiply negative 1. So negative 1 raised to the power k. Next, we factor in plus. That is plus k times gamma 1. So gamma 1. And this is multiplied by k. Then enter. So if k equals 1, the expansion approximates the probability density function, and the polynomials approximates that of the probability density function. At k equals 0, the expansion approximates the cumulative distribution function. Likewise, it's also on the dataset. Let's check the coefficients. So at x to the 0, this is 1, this is 0 because 3.96 times 10 to the minus 3 and 33, and 5.15 times 10 to the minus 33, that's 0. And this is negative 0.99, positive 0.99, positive 0.99. X squared, 0.497, 0.497, 0.497. X cubed, minus 0.16, minus point, plus 0.16, plus 0.16. X to the fourth, 0.0356, negative 0.0356, negative 0.0356. X to the fifth, negative 4.99 times 10 to the minus 3, negative 4.99 times positive 4.99 times 10 to the minus 3, 4.99 times 10 to the minus 3. X to the 6, 3.3 times 10 to the minus 4, and negative 3.3 times 10 to the minus 4, negative 3.3 times 10 to the minus 4. So we change this to 1. The expansion approximates the probability density function, the same thing as the datasets. So this completes the use of array formula, data validation in the series sum to show the Taylor-Maclaurin series sum of the incomplete gamma function for the EXPONDIST.